So this lesson is going to kind of combine the concept of a two-dimensional area and a three-dimensional volume. And I've got this great visual demonstration for you guys to see to help make it clear. So in looking at this, these two functions, I've got y equals x and y equals x squared minus 1. So I have, there's my linear line, and there's my parabola that comes down 1. This yellow part is the enclosed figure. So I could find the area of this figure. I could pick an axis of rotation. I could rotate it around that axis and find the volume. But what we're going to do today is we're going to take this yellow shape, this figure, and we are going to lay figures on top of it. So here's what it's going to look like. I'm going to do squares. So what I'm taking is a square, and I'm laying it, if you can come over here and see the arrow, I'm laying it from end to end of this shaded region. But the square sits upright, so it sits vertically on this graph. And I think this over here to the right gives a great visual demonstration of what that looks like. So you can see, now it's a square, so whatever length this width is right here is also how tall it's going to be. So if this area were to get bigger, then the square would get taller. Okay, now watch. I'm going to slide the square down my shape. So now the base of my square is way up here where the length of the square is going to be smaller. And then if you'll look, you'll see I've got a smaller square. It's still vertical, it's still sitting on top. And then I can go even farther up and it's going to get even smaller. And the reason the square is getting smaller again is because the base is smaller and it's a square, therefore the height is getting smaller. So as I drag it, you can see it getting bigger and then it's going to start to get smaller. So I have got the base, which is my parabola and my linear line. They've got this enclosed yellow region, shaded yellow region. And what I'm doing is I'm going to slice, I'm going to lay on top a whole bunch of squares. So then if I do this, if I make a whole bunch of squares, now look at what it looks like. So right now I've got 9 squares. That's what it looks like flat. Okay, now watch. I'm going to increase. How about right there? I'm going to increase the number of squares. So now I'm at 17 squares. So you can see how it's kind of filling out. So that's cool. You can see how it's filling out the shape a little bit more solid. I've got a little less free space in between there. And you should know that it's taller in the middle because that's where the base is the widest. And again, this is a square, so length and width are exactly the same. And then as it comes over here, it's getting shorter because the base is less wide. All right, and then if I want to go, let's go to 42 squares. So now I have 42 squares in here. So no, it's not a solid figure, but those squares are kind of shoved in there. So now, let's see if I can go back. So now let's talk about, I want to find the area of all of these squares. but I want to find the area as if there are an infinite number of squares. So it's kind of like the limit. And we know that integrals find the accumulation from here to here of a certain region. So what I need to do, and you can see the A right here in this red dotted line and the B. So those are there because that's where these two functions intersect. So I still need to find where they intersect. So I'm going to take the integral from wherever A is to wherever B is of the area of each of these squares. And the square, the area of a square is length times width, but a square, because it's the same, the length and the width are equal. So it's just going to be like the length squared or the width squared. To figure out what the length or the width is, all right, so now I'm underneath. I need to know, let me bring this down so we can see our squares. I need to know this distance because that's the length of the base of all of these squares. And that distance is going to be my, hold on, there we go, my linear line minus my parabola, top minus bottom. Because there's the base of my square. So it's going to be from here to here squared. Okay, but here's the kicker. I don't have to just do squares. Okay, so let's take squares off and let's do, let's do a semicircle. So here we go. There's your semicircle. Kind of see him sitting on top right there. So he's flat. He does not go through the bottom or through the back side of the graph. And then if I wanted a bunch of them, this is kind of what it would look like. And then you can have more of them and it just fills the shape in. Okay, so if I was going to lay semicircles on top of this, the area of a semicircle, that's half of a circle, so that's pi r squared over 2. So I would integrate from A to B of pi r squared over 2. Okay, so well, the question is, what's your r? Well, r is the radius. Okay, well, this cut right here is the diameter of my semicircle. So the radius would be half that. So I would have pi r squared over 2 because I'm half a circle. But remember that your r is not the distance from here to here. Your r is half the distance from here to here. So I would do x minus, parentheses, x squared minus 1 over 2 because that would be the radius. The whole thing is the diameter of the semicircle. So the radius would be half that. And we'll practice. We're going to practice all this. Okay, so now let's see what a circle looks like. So a circle is going to cut all the way through and bubble out on the back side. So this one's really cool to look at. Let's see if I can get a good angle. Okay, so let's go solid. Let's pull this down a little bit. So here we go. Here's all our circles. We have 20 of them. And there it is. It bubbles out the bottom. So the area of a circle is pi r squared. And I want the whole circle. So I would do the integral from a to b of pi r squared. But again, to get r, this cut right here is the diameter of my circle. So my r would be half that. And then I can also have an equilateral triangle. Let's make sure we remember what an equilateral triangle is. And that's where all three sides are the same. So there is my equilateral triangle where one of my legs or one of the sides is sitting on the two-dimensional graph. Let's make it solid. Let's pull it down just a little bit so you can see them. So there are all your triangles. There they are. So you would need to know the area for an equilateral triangle, which is not one of these super common, hey, we use it all the time area formulas. So an equilateral triangle is a side squared, and remember, it doesn't matter which side because they're all the same, times the square root of 3 over 4. So that's something that's going to have to get put back into your memory box so that you can remember, because they will not provide that for you. Okay, so now that we've kind of had our demonstration, now let's do some. So here are the area formulas that you need to know. I would say it's safe to say that we all know that that the area is a side squared, not a problem. And I think that we're pretty cool on the fact that a circle is pi r squared. But I just want to caution you to be careful for what your r is. Remember, r is half the distance all the way across the circle. Now, semicircle, you can look at this two different ways. A semicircle, you can do pi r squared and then half it. Or you can do diameter squared times pi over 8. If you don't want to memorize this one, and this is a good one when you know what the diameter is, but also know you can just take this formula and think about what your radius is in terms of your diameter. Well, your radius is your diameter over 2. So that's d squared over 4, which would be 1/8 pi d squared, which is exactly what this is. So if you can memorize the diameter formula or the area of a semicircle using the diameter, that's great. But if not, you can always take this guy and just go derive it. That's fine too. A triangle, 1/2 base times height. An equilateral triangle where all the sides are the same is a side squared times root 3 over 4. And an isosceles right triangle, so an isosceles right triangle, so right triangle means those two sides are equal, but the hypotenuse is not. So if it's laid with its hypotenuse on the two-dimensional shape, then it's 1/4 hypotenuse squared. If it's laid like it is right here with a leg on the base, then it's 1/2 base squared. Right now, I don't want you to fret about memorizing the formulas. Let's just get comfortable with the process. So lean on these formulas as much as you want. And once we get super comfortable with them, then we'll start worrying about memorizing. Okay? Okay, here we go. So this is what one of these problems is going to look like. Find the volume of the solid whose base is x squared plus y squared equals 4, and where cross sections perpendicular to the x-axis are all squares whose sides lie on the base of the circle. Okay, so first of all, you are expected to know that that's a circle centered at 0, 0 with a radius of 2. And that's from Math 3 and from Pre-Cal. So Let's see if I can draw this so it does not look like a potato. There we go. It's not bad. Okay, so there's my base. There's my two-dimensional shape where everything's going to lay on. Okay, so now my cross sections are perpendicular to the x-axis. Okay, well, this is the x-axis, and I'm going to go perpendicular to that, so my cross sections are going to go this way. So that's where the shape is going to lie. Now let's figure out what shape that is. And it says that it's a square. Okay, now I am not a good drawer, but how's that? So here is the base of your square. This is not a square at all. Here's the base of your square. That's the part that's on the board. Then this is sticking straight up, and then this piece right here is parallel to this piece up in the air. Okay, so what I need is I need the area of my shape that's sitting up, and that's a square, so that's going to be side squared. Okay, so let's figure out what a side is. Well, the side is this length. Okay, so think about that. That's this part right here is y, wherever you cut it. Even if my square was here, this distance right here is y. And even if it was right here, that distance is y. So the distance of each, the length of each side of each square is 2y. Because I've got this and this, and it's symmetrical, so it's the same height. So I could have a square here. The base of my square could be there, could be there, could be here, could be here, could be right there. So that's the foundation of my square, and then the square goes vertically out of the smartboard from that. Okay, so now I need to replace my y. I need to put this in terms of x. So if I have x squared plus y squared equals 4, I can solve that for y. So y squared equals 4 minus x squared. And then I'm going to root both sides. And I'm going to get plus or minus the square root of 4 minus x squared. The plus or minus makes sense because you know that the square root of 4 minus x squared is a semicircle. So then the negative version of that gives you the bottom semicircle, which is what makes it a full circle. So I am now going to plug this. I'm going to take the plus or minus off because I'm multiplying it by 2. Not because that makes everything positive, but because I'm multiplying this distance by 2. So it is a distance, a positive distance. So 2 times the square root of 4 minus x squared. And then all of that is squared. So there is my area of each individual square in terms of x. So now what I want to do is I want to accumulate all the areas. So I want the integral. Okay, so now I need to know from what to what. Well, I want to go from here all the way to here. Well, on this one, that's super easy. I know it's going to be from -2 to 2 because I drew this circle with a radius of 2. So I'm going from -2 to 2. Okay, so now I'm gonna clean this up because I can't integrate this as is. I can't do u sub. I don't have enough x's to go around to do u sub. So I'm going to clean this up. So I'm going to square the 2, and that's going to give me 4. And then I'm going to square the root, so that's going to cancel the root. And then I'm going to distribute my 4. Okay, so that's just me prepping the problem to be able to integrate it. So now I'm going to integrate 16 minus 4x squared dx. So guys, what you're doing is you are integrating from -2 to 2. This is the formula for the area of each square. And the integral adds all those together. So let's see, I've got 16x minus 4/3 x cubed. And I'm going to go from -2 to 2. So if I plug in a 2, 2 times 16 minus, all right, let's plug in a -2. Minus, so 32 minus 32 over 8 minus -32 plus 32 over 8. I'm going to run my negative through. So 64 minus 64 over 8. Oh, hold on. Goodness gracious. Where did that over 8 come from? That should be over 3. So sorry. Okay, let's try that again. Okay, so the 64 is good. And then the minus 64 over 3. Okay. Put this over 1. Multiply the 64 by 3. 192 over 3 minus 64 over 3. And if this is an FRQ, you can stop. If it's multiple choice and it's calculator inactive, you got to keep going. $128 over 3, and its volumes. There you go. Okay, if that set well with you, awesome. Go on to number 2. If it did not, I want you to pause it, rewind it, and go back and just watch example number 1 again. But don't move on to example number 2 until you're solid with number 1. Okay, number 2. Find the volume of the solid whose base is, and that's that same circle we were dealing with, where the cross sections are perpendicular to the x-axis and are all equilateral triangle whose sides lie on the base of the circle. Okay, so I've got my circle whose radius is 2. I'm going to slice it perpendicular to the x-axis, and I have equilateral triangles. So pretend that's sticking out of your paper. Okay, so first I'm going to find the area of an equilateral triangle. And that is side squared times root 3 over 4. So right now I'm not doing any calculus whatsoever. I'm finding the area of one triangle, or I'm finding the formula for the area of one triangle. Okay, so a side squared. Well, a side, now equilateral means all three of these sides are the same. So I need a whole side. Well, again, we talked about in the first example that that distance is y. So the whole thing would be 2y. So 2y squared root 3 over 4. Okay, but I don't want it in terms of y. I want it in terms of x because I'm slicing vertically. So 2 times the square root of 4 minus x squared. Squared times root 3 over 4. Okay, so what I just did is I replaced him with him because that's what y equals when you solve that circle formula for y. And that's, I just got that off of number 1. So now I'm going to square this and this. And I don't have to lobster because these two things are being multiplied to each other. So that would be 4 times 4 minus x squared times root 3 over 4, which would be, well, you could either distribute this 4, or you could see that this 4 and this 4 can cancel. I'm going to go that way. So root 3, 4 minus x squared. And I'm not going to distribute my root 3. I do not want to integrate with a root 3. And he's kind of very nicely sitting out front. So when I do my area, I'm going to pull my root 3 out. Negative 2 to 2, again, it's the same semicircle from number 1, of 4 minus x squared dx. So again, my area was side squared. There's my side squared. There's my side in terms of x squared. I went ahead and squared it. Then I'm cleaning all this up before I go into my integral. Okay. So I'm root 3, 4x minus 1/3 x cubed. Okay, so root 3, 8. Let's see if I can not mess this one up. Okay, so there's the 2. Now let's go negative 2. I'm going to run my negative through. Combine my like terms. I'm going common denominator. (32 thirds) root 3 units cubed. There it is. Okay, again, feel free to pause, rewind, go back and just watch it again. This is difficult to learn when you're in class. So learning it via video is going to make it more difficulter. So take your time. Okay, number 3. I got this same base, I got this same circle. Cross sections perpendicular to the x-axis are all semicircles. So now what's happening is I have my base and I have a semicircle sitting on top of it. Okay, well, a semicircle you can do 2 different ways. If you flip back and look at the front, your area can be diameter squared times pi over 8, or your area can be 1/2 pi r squared, half of a circle. Okay, so let's think about which one would make more sense here. So the diameter, if I use the first one, the diameter is all the way across, which would be 2y. The 1/2 pi r squared uses radius, which would just be halfway, which would just be y. So if I were to start this one, this would be 2y squared pi over 8, which would be 2 times root 4 minus x squared squared pi over 8. This one would be 1/2 pi, which could all be brought out front. And then my radius, which is just y squared. So 1/2 pi root 4 minus x squared squared. You will get the exact same answer either way you go. I'm going blue. I'm going radius. It just seems to have less stuff. But I will show you how they'll both end up to be the same. Okay. So this is 1/2 pi, and then if I square the square root, the 4 minus x squared is going to come out. Okay, now step back over here to the purple. So if I square this and this, that's going to give me 4, and then that root is going to go away. And then you could distribute the 4, or I could reduce the 4 and the 8, and then I have pi over 2, 4 minus x squared, which is exactly the same. Now, in my opinion, the 1/2 pi r squared is easier, but it's just easier by like 2 steps, so it's nothing drastic. So you figure out when you're doing your homework, you figure out which way works best for you. All right, so I'm going to take either one because they're the same, and I'm going to integrate from -2 to 2. I'm going to pull my 1/2 pi out front because there are no variables in him, and he's being multiplied by the whole thing. Okay, now I am not all about doing extra work, so let's look right here. Isn't that the same as that? Which means all but the root 3, which means this is the answer to that. 32 over 3. So that means that this piece right here, so then I just have to multiply it by my extra and get 16 pi over 3 units cubed. Okay, moving on. Okay, so finally we have a different base figure. So find the volume of a solid whose base is the region between the x-axis and the curve y equals 4 minus x squared, and whose cross-sections perpendicular to the x-axis are equilateral triangles with the side that lies on the base. Okay, so first let's start with your base figure. My base figure is a parabola that goes up 4 and opens down. I have a feeling I'm going to need to know who they are. So I'm going to set 4 minus x squared equal to 0. and I can see that I'm getting plus or minus 2. Okay, so I have the base parabola, and it says between the parabola and the x-axis. So my shaded region is this. And I hope you guys can already start to see how this would be a fantastic FRQ, because this shape right here, part A, I could ask you for the volume. I mean, for the area. Part B, I could ask you for the volume rotated around the x-axis. Part C, I could ask you for the volume rotated around a different axis. And then part D, I can ask you to find the area of cross sections. So, I mean, this is such a big, powerful topic that they can put into an FRQ. It's just so easy. So this is something you want to make sure that you really have a good foundation and a good grasp on. Okay? All right, so this is my base figure. We're doing cross sections perpendicular to the x-axis, and the shape are equilateral triangles. Okay, so I need the area of an equilateral triangle, which is side squared root 3 over 2. So now I just have to think about what a side is. Okay, well, a side for this equilateral triangle is the distance from here to here, which is y. So y squared root 3 over 2. But I don't want y's, I want x's because I'm slicing vertically. And y is 4 minus x squared. Squared root 3 over 2. So there's my area. But I know that I'm about to integrate this, so I'm going to fluff this out a little bit. I'm going to leave my root 3 over 2. I'm going to leave him out because when I integrate, I'm just going to pop him out front of the integral. Okay, so I wrote that twice and folded out. And now I'm ready to find the volume. So the volume, let's see, I'm going to leave these guys out here. Minus 8x squared plus x to the 4th dx. Good notation. And then I'm slicing from -2 to 2. Okay, so I'm going to give you like a 30-second head start. I want you to start integrating and then plugging in and doing all that fun math, and we're just going to assume this one is no calculator to practice those algebra skills. So dive on in. All right. So the very first thing I wrote down is wrong. That right there is supposed to be a 4. I hope you caught that, or at least noticed it, and then went along with me. That's fine. And this is really easy to fix because this guy didn't come into play until the very, very, very end. But it's root 3 over 4. So that should be a 4, and that should be a 4, and that should be a 4. It doesn't change any of the calculus we've done. And that's a 4, and that's a 4, and this is a 4, and I reduce it with a 2. So now this is still over 2 times 15, which is 30. And I think I can hack at them both with a 2 again. That'll be a 1, 2, 8 over 15. There it is. Completely my fault. I just looked at the formula too quick. It's not root 3 over 2. I was thinking the unit circle with root 3 over 2, and it's not. It's root 3 over 4. Oof. All right. So besides that little mistake, I hope that the process is starting to sink in. And guys, honestly, they will totally give you one with this kind of a common denominator, and expect you to do it by hand. So be prepared and be quick about it. Like you don't have time to, oh my gosh, I've got to go multiply all this stuff out. Like just go do it. Just go multiply, go add, subtract. Be sharp on your 3rd grade algebra skills. You don't have time to sit here and contemplate how do you do 2 digits times 2 digits. That just needs to be second nature. So practice that. Okay. And then make sure you write the right area formula down, from step number 1. That's important. Okay. Last one, number 5. Find the volume of a solid whose base is the region between the functions. Okay. Now those are just linear functions. That's 1 minus 1/2 x and negative 1 plus 1/2 x. And the line x equals 0, and whose cross sections perpendicular to the x-axis are equilateral triangles. Okay, so at least I have a chance to redeem myself with the equilateral triangle formula again. So this guy right here is y equals, and I'm just going to kind of write it how we're used to seeing it, negative 1/2 x plus 1, and the other guy is 1/2 x minus 1. So I'm going to go graph these. I'm going to go up to 1 and put a dot, and then my slope is a negative 1/2. So down 1, right 2. So there he is. And you know what? I'm going to label him. And then I'm going to graph the other guy, which is down 1, and then up 1, right 2. And I'm going to label him. And then it also said the line x equals 0. That is a vertical line. So make sure you're super clear on which ones are verticals and which ones are horizontals. X equals are all vertical lines. So he's going to come in here. Pretend that was straight. So my shaded region is that little triangle right there. And I am slicing it with an equilateral triangle. I'm slicing a triangle space or base with a vertical triangle. So here's the base of my triangle. And that's it. That's my 3-dimensional version of a triangle. Sorry. Okay. All right, let's see if I can get this step right. So it's side squared root 3 over 4, not root 3 over 2. Let's see, the side. Okay, now this is the first one we've had where the top and bottom are bounded by two completely different functions, where one of them's not a 0. So my height is not 2y here, like it was on 1, 2, and 3. My height is my blue line minus my purple line. So a side is the negative 1/2 x plus 1. That's the top. Minus, now notice I'm going to put the bottom in parentheses, 1/2 x minus 1 squared root 3 over 4. So this is top minus bottom. Okay. So now I'm just going to clean it up. I'm going to run my negative through. So that would be negative 1/2 and a negative 1/2, so negative 1x, and then plus 2 squared root 3 over 4. I'm going to kick the root 3 over 4 out. I'm going to multiply this together and get a positive x squared, then a negative 2x and a negative 2x, so negative 4x, and then plus 4. So there we go. There's the area of one equilateral triangle. Okay, so now I'm going to integrate. I'm going to put my root 3 over 4 out front. One triangle in the middle. What I don't know yet is from where to where. Now normally this is where you would set stuff equal to each other, but I know that it's cut off at this line, x equals 0. So I know I'm going from 0 to, now normally this is where I would set the blue line equal to the purple line and solve for where they intersect, but I graphed these lines and that was a point for both of the lines, so I know they cross it too. If I was iffy about it, if I were to solve this, I'm going to add the 1/2 x over and then add the 1. And you can see that you get a 2. All right, so I'm getting root 3 over 4. Do not just write down what you're seeing. Do it yourself. Don't let your brain, this is just practice for integration. So let your brain practice that. Okay, now tell you what, pause the video, plug your 2 in, plug your 0 in. Yay, plugging in a 0, that makes it nice. Get your answer, and when you've gotten your answer, push play and see if you're right. There you have it. The 8's canceled, and then I reduced the 4 and the 8 there instead of multiplying first. Okay, so the only thing that extra that I want to point out is if you have something like this, and you have a cross section whose base does this, let's say it's a semicircle or a circle, then I want you to think about what your R would be. Would your R be Y or would your R be 2Y? And here your R would be Y, and I know this would be better if it was drawn symmetrical, but your radius is half of this line, which is Y. But if you have something like this, where this is the shaded part, and you're slicing it this way, and let's say we're slicing it with a semicircle, your R is not just y. If this is the whole semicircle, the whole distance is y, the diameter is y, the radius is y over 2 because it's only half that distance. So be careful. If your figure straddles the x-axis, then your radius is y. But if your figure sits completely above it, then your radius is just going to be half of y. Okay, so again, this is a tough topic to learn, period, much less through a video. So make sure that you're solid before you go do the homework. 1, 2, 3, 4, 5, 6. You only have 6 problems for homework. Take a second and let's look at that. So the directions say draw a graph, so I want a beautiful graph. Express the volume as an integral. Then evaluate the integral on a calculator to get the solution. So I'm going to totally let you go decimal here for your answers. So we're focusing on the graph, the integral, and then making sure you can type it in and get the correct answer. Do not stare at my homework answers while you're doing this. I want you to try drawing these from scratch. I want you coming up with the integral from scratch. Then go check my answers, then type it in and get the decimal answer and check it. But you only have six examples. And then if you keep flipping, you'll see the next thing we have is our test review, which we will address. I'll address that probably on Wednesday, later on this week. So today your job is to make sure you're good on the video and the notes, and then go tackle that homework and just send me any questions that you have. I'm always happy to help.